Hey everyone, Professor Baldwin here. We have another problem where we have a polynomial that we need to solve and check with. And remember, to solve it, we're going to factor it first, then use our zero product property, and then check our answers. Remember, checking is the most important step. Since this is in standard form, all the variables are on the left and it's equal to 0, we'll start with factoring. Do we have a GCF? We do. Our GCF is 10. Factor out that GCF of 10, and we have a polynomial of 3y squared plus 5y plus 2 equals 0. Now we can continue factoring and factor this polynomial that's left inside the parentheses. But first I'm going to show you that we can divide both sides by 10. And when we divide both sides by 10, these simplify out, and on the left we just have 3y squared plus 5y plus 2. And then on the right we have 0 divided by 10, or just 0. So we're left with that polynomial, and it's in standard form. So this polynomial has a leading coefficient of 3, so we're going to use the key number method. A times C, which is 3 times 2, or 6, and B, our middle coefficient, 5. And our goal here is to rewrite that middle term of 5y so we can factor it easier. And to do that, we need to find two values that multiply to 6 and also add to 5. You got it, 2 and 3. So 2 and 3 help us rewrite our middle term. The first term stays 3y squared, and our middle term will be, I'll put the 3 first, 3y plus 2y plus 2 for our last term equals 0. And notice that we rewrote that middle term and it gave us 4 terms. 4 terms, factor by grouping. The first 2 terms, we can factor out a 3y, and we're left with y plus 1. So ideally, our second grouping should have a binomial of y plus 1, and to do that, we factor out a positive 2. And it's still equal to 0. Now we factor out that binomial they have in common, y plus 1, and it leaves the binomial 3y plus 2. And those two factors equal 0. So now that it is factored, we're going to use the zero product property, or y plus 1 equals 0, or the factor 3y plus 2 equals 0. And we'll solve each of these to determine possible solutions for y. The first one gives us y equals negative 1, and the second one, subtract 2, we have 3y equals negative 2, divide by a 3, y equals negative 2/3. So these are our possible solutions, and remember that our most important step is to check, and to always check these with that original equation, which is this, 30y squared plus 50y plus 20 equals 0. Now, I'm going to tell you that y equals negative 1 does check, because that's a relatively easy one to plug in and check. I'll walk you through y equals negative 2/3. So we substitute in our negative 2/3 every place we have our y. I know fractions give people anxiety, so I want to show you that if you take it slow, it's really not that bad. So, order of operations. We need to square this negative 2/3 first. That becomes 4/9, and it's multiplied by 30, or 30 over 1. And this middle term, 50 times negative 2/3, remember 50 is the same as 50 over 1. So we can multiply those together to get negative 100 over 3. And plus 20. We'll leave that alone for now. We're just going slow. Back to that first term, 30 over 1 times 4 over 9. Well, that would be 120 over 9, which then we're going to simplify. Or notice that the 30 and the 9 have a 3 in common. So we can simplify those down to 3 in the denominator and 10 here in the numerator. So that would give us 40 over 3. See how this is helpful? Because our second term is negative 100 over 3. Common denominator. And then we have that 20, which we're just going to leave that 20 alone for now. 40 over 3 minus 100 over 3 is negative 60 over 3. Plus 20 equals 0. Now negative 60 over 3 simplifies very easily. 60 divided by 3 is 20. And we keep the negative sign. And look at that. Negative 20 plus 20 equals 0. I agree with that. So our final answer is y equals negative 1 or negative 2/3.